Hey guys, today's March 24th and I'm going to do another LeetCode Daily Challenge. So we've been doing a lot of graph problems and then yesterday was an interval problem. So let's see what today is. Check if grid can be cut into sections. You are given an integer n representing the dimensions of an n by n grid with the origin at the bottom left corner of the grid. You are also given a 2D array of coordinates, rectangles, where rectangles I is in the form of star x, star y, and x and y. Representing a rectangle on the grid, each rectangle is defined as follows. Start x, start y, the bottom left corner of the rectangle, and end x and y is the top right corner. Okay. Note that the rectangles do not overlap. Your task is to determine if it is possible to make either two horizontal or two vertical cuts on the grid such that each of the three resulting sections formed by the cuts contain at least one rectangle. Every rectangle belongs to exactly one section. Return true if such cuts can be made, otherwise return false. Yeah, I'm just kind of a little bit confused by what they're saying, but I think it makes sense. I don't really understand what does 1052 represent. So x is probably like x1, y1, x2, y2. So 1 comma 0 is right here. And then 5 2 is right here. So that's one of the rectangles. And then I'm assuming this is then, okay, let's see. Just so that I know more. So this is rectangle at index 0. 0, 2 to 2, 4. This is rectangle 1. 3, 2 to 5, 3. 3, 2 to 5, 3. This is rectangle 2. And then this is rectangle 3. We could make horizontal cuts. In this case, we're making two horizontal cuts. So yeah, I mean, just reading this problem, it seems kind of tricky because I feel like I don't have that much experience with like rectangle type problems, but it does seem like those interval problems, right? Because like if we just considered this problem like on a one-dimensional space, like let's just say they weren't rectangles, maybe we just looked at the x's. Oh, and maybe that's what we have to do. Since x's and y's are are like two separate things, right? Like x's will just be responsible of holding like horizontal. Well, I guess if we have a bunch of horizontal slices, this is like an interval, right? This is like intervals. And then all we need to say, like, what if there's an overlap, right? So you can see how these are all a bunch of horizontal intervals, and that represents the x. So we will try to make vertical cuts on the x, as opposed to if we were just to look at the y has a lot of, it might have a lot of different heights like this, right? And then our job with the y is to make a bunch of horizontal cuts going this way. So let's see. And then what does this say? Rectangle this at 0 is less than 2. Okay. They're not guaranteed that the order is sorted, but at least x1 is less than x2, which is good. Okay, so sorry. I stress out about these intervals so much. Okay, so this is just like another like interval type problem. And I think we're just gonna like split it into two parts. We're gonna work with like x intervals and y intervals. So with x intervals, we want to try to split vertical. And then with the y intervals, we want to try to split horizontal. And then well, what's the condition one more time? Return true if the yeah, so let me get these intervals separated to start. For it's x1, y1, x2, y2 in rectangles. So we want x intervals to be this, and they're going to have, it's like intervals, right? So it's going to be like this, the x start and then the x end. And then very similar for the y intervals, except we're just going to be looking like vertically. So it's going to be the y start and the y end. And there's just going to be a bunch of these because it's going to be a list. So just x intervals dot append x1, x2, y intervals dot append y1, y2. So I'm just gonna try horizontal for now. Oh, so this was a better example because this one does horizontal. Let me just print out the x intervals as well as printing out the y intervals just to help us. And I'm also going to sort these. X intervals dot sort, y intervals dot sort. Return false for now. This is the x intervals, and then this one is the y intervals, right? So x goes from 0 to 1, and then we see 0, 3 as well. Then we see, oh, sorry, we see 0, 1, then we see a 0, 2, then we see a 2, 3, and then a 3, 4. So just looking at this pattern, I could see that there's some overlap right here, right? So maybe I need to count the number of overlap. And then also we know that there's 4 rectangles, right? Like that's kind of obvious. It's just the length of the rectangles. So we know that the total number of rectangles is 4. And if we see one overlap, and then the rest don't overlap, that means we could do the total number of rectangles minus the overlap. Maybe I'll do that. Total rectangles minus the number minus the overlap is going to be equal to the number of rectangles that can be split. Right, so since this is overlapping, that's one count right there. 2, 3, and 3, 4 don't overlap, so that's another, so that's 3. And then 4 minus 3, or, oh no, that's 3. Oh yeah, sorry. We're only counting the overlap, so there's only one overlap. So 4 minus 1 is 3. And 3 just needs to be greater than 2, and then we could return true. So let me see for this example right here, that's a case 1. This is our x, right? So let's see. This is our x right here. 0, 2, 0, 4 overlaps. 1, 5 overlaps as well. And then 3, 5 overlaps. So like this whole thing overlaps. So if we do the 4, oh wait. Um, Maybe we want to count how many like separate, like non-overlapping. So this one's kind of weird. Maybe we just want to count how many non-overlapping intervals, right? So in this case, these are overlapping, so we merge them together to be one. And then 2 and 3 doesn't overlap with the one previous, so that's another one. And then 3, 4 is its own. So we have a total of 3. And then we just know that like 3 is greater than 2. Or 3 is greater than or equal to 3, right? Yeah, because we just need it to have 3. 3 sections. Or 3 is greater than or equal to 3. Must be greater than or equal to 3. So then if we look at this one, there's only one big interval right here because they all overlap. So since 1 is not greater than or equal to 3, this is false for the horizontal. Okay. Um Okay, now let's look a little bit deeper into this. And maybe we could draw something similar to yesterday. Now that it's all sorted, we just have a start and end. And then a new start and a new end. Sorry, I'm showing this really bad, but okay, maybe we have a previous end, which is going to be x intervals at 0, 1. It's right there. And then we just do for, we also need the count, right? Maybe we start count as 1 because we're dealing with the first interval. Okay, so then we do for new start, new end in x intervals starting at 1. What happens if the new start, like if we had this interval, oh wait, if we had this interval in a number line, and then we had the new start be here, so this is our previous end. This is our previous end, and then this is our new start. If the new start is greater than or equal to, right? Because if the greater than or equal to right here, we still count it. So if it's greater than or equal to the previous end, then we know that we are now starting a new interval. So we could put a horizontal line is what I'm saying, or a vertical line. So count could go up by 1. Now, even though count started at 1, so count started at 1, right? And then when we see new start is greater than or equal to previous end, just like this, now our count is 2. That makes sense, right? Because this is when count is 1 right here, and now this is count is 2. So we're just like saying how many sections. So maybe to be more specific, this could be like sections, right? These are how many sections. And we want our sections to be at least 3 in order for something like this to work. Okay, So what happens if the interval looks something like this, where our new start is not greater than or equal to new n? We just don't have the same section, but maybe the interval was even shorter here. We just need to update our um, previous n to be the max. So it's either that or it's this, right? Because we don't know. So we just need our previous n to be the max of the new end, or the max of itself, or the new end. And then all we need to do is just return sections greater than or equal to 3. I think. But okay, there is something we need to consider. This is just for x. And since I'm doing return, we could just make a, this is possible. And maybe it could take a list, right? Like an interval list. And it's going to return a bool of whether we can do it like in the x direction or in the y. And then instead of x intervals, this is just going to be intervals with an s. And then instead of x intervals, it's just intervals. I think that's fine. It's going to be like that. All we need to do is call is possible given x intervals. And then we need to call is possible with the y intervals as well. Because like, the reason why I'm not really drawing an example going like all this vertical stuff is because if we just like flipped our image, all of a sudden that just becomes a horizontal problem. So if we solve it horizontally, we could solve it vertically the same, right? It's just how you visualize it. All I have to do is just return, we want either of these to work. So this or that. Let me go ahead and run this. Okay, that works. And then I'm gonna submit. Awesome. Yeah, I'm starting to get the hang of these interval problems again. I was a little bit rusty. I don't like my explanation on these. It's not that clear. But the code's not that hard to understand, right? Like just this is like the whole crux of the problem. We just basically want to count how many non-overlapping sections we can create. And this is actually a really good example because given these like first two intervals, even though there's two intervals, we can't create two sections. We could only create one section because they overlap. And that's my check right here. If they don't overlap, just like the yellow and blue rectangle, those don't overlap, right? Then we should update our sections to be here's one section and then here's another section. And then like they said, they were very explicit about it. They said that there needs to be there needs to form like 3 sections, right? And each section must have a rectangle, which is like given. And then once you understand it, like with the x as intervals splicing down vertically, since it's just a rectangle, we can just flip it. And then now you could do that exact same problem, but this time you consider the y, like all of these lengths, right? You could do the same thing, just considering this. And then instead of a vertical slice, we'll just be slicing it horizontally. Okay, so what is the runtime? N is the length, right? Oh, I didn't even use n for this problem. But n is the... Oh, n is like the max. No. This is just going to be the length of the rectangles. Let's just call that like m. So sorting is going to be the hardest part about this, right? So sorting is m log m. And then this is just linear. So m log m. And then I am using some additional space, right? Because I'm kind of separating the original rectangles into two lists, one to just to store the x intervals and then one to store the y intervals. So that's just going to be O of m extra space, O of m log m, and then m is the length of the rectangles. That's how many intervals we have. So yeah, hope you guys enjoyed this video and see you tomorrow.